welcome to part 2 of our Mid Latitude Cyclones chapter. Now on the previous lesson, we looked at the general characteristics of a mid latitude cyclone. We looked at the areas of formation. Number 3, we looked at conditions now that are necessary for a mid latitude cyclone to form. And lastly, we looked at the 4 stages of development. The first one being the initial stage, then we had the mature stage, occluded stage, and the dissipating stage. So namhlanje we are continuing with our previous lesson. Now before we start this lesson, let me remind you of what we said about the mid latitude cyclone previously. So when we draw a diagram of a mid latitude cyclone, we said it is within a low pressure system. So it is within a low pressure system, and inside here it is represented by a pair of a cold angate. It also has got a warm front. But now on the occluded stage, we said it also has got an occluded front. It also has got an occluded front. So today the first thing we're going to look at, as you can see, we're going to look at the weather patterns that are associated with the cold front. This is your cold front. How are the weather patterns now within that cold front? Then we're going to look at the weather patterns within a warm front. And lastly, weather patterns within an occluded front. And now part 2 of our lesson today is going to be about reading and interpreting satellite images and synoptic weather maps. Now that one is very important, guys, because during your examinations now, this is where all your hard work will be revealed. Okay, good. So let's get started. Okay, so this is what I just explained to you guys. This is just a reminder of what we said previously. So we're saying the cyclone has a warm front and a cold front. This is your cold front and this is your warm front. There is cold air ahead of the warm front. Oh, so as you can see, we told you last time, this is your cold front. Behind the cold front we've got cold air, and behind the warm front we've got warm air. But now the other thing that you should know is that around the warm front it consists of only cold air. So we only find the warm air in the middle of our mid latitude cyclone. We find the warm air in the middle of our mid latitude cyclone. All right, good. And now we're going to discuss the types of clouds that are found within each front. Right. So I'm going to come back to these images. These 4 images, I'm going to come back to these images. Right, so let's look at the first one, which is the cold front. The cold front. So how are the weather conditions within our cold front? Let's talk about the air pressure now. Before the arrival of the cold air, okay? Before the arrival of the cold air, what happens to our air pressure? As you can see, we're saying the air pressure is going to drop to its lowest. The air pressure drops to its lowest. Now remember, guys, when the air pressure drops now, what does that mean? It means that we've been having warm rising air. We've been having air rising. Now when that air rises now, the air is going to rise to form clouds now within our atmosphere. So this is how these cumulus and larger cumulonimbus clouds are going to form. Alright, but then after the arrival now, after the cold air arrives within our cold front, then the pressure increases now. Then the pressure is going to increase. What's causing the pressure to increase is because, remember, we always say that cold air equals to is denser. Cold air is denser, it's heavier, therefore it's going to subside. But now when it subsides, it causes our pressure to increase. All right, you still remember that one? Very good. Right, now how are temperatures now within our cold front? Now here's an area, then cold air arrives within this area. What happened to the temperature? Obviously it's going to get colder. Just like when you're in a room, then you switch on your air conditioner. You're switching your air conditioner to cold air. then the room is going to get cold because of that cold air coming from the air conditioner. So when this cold air now, when this cold front arrives, the temperatures are going to decrease now. Then what happens to the humidity? Humidity also decrease now. Okay, so we've got a high pressure. We said the pressure increase, we said the air pressure. What's happened to my pen? Okay, so we said the air pressure increased. Now we've got a high pressure. Now at a high pressure, do we have rising air or subsiding air? Yes, I just told you we've got subsiding air. Now if our air is subsiding, that means we don't have evaporation. Therefore, humidity is going to decrease. We're not going to have any moisture within the atmosphere. Are we good? Good. Right. So then, because of these cumulonimbus clouds that formed, guys, because of that pressure that dropped to its lowest, now, because of that air pressure that dropped to its lowest, and it formed these cumulonimbus clouds, we're going to have heavy rainfalls. We're going to have heavy rainfalls. Sometimes there could be even a snow. Now, I want you to pay good attention to these names. Cumulonimbus clouds. Cumulus clouds, right? Can you see now that the way they are pronounced is almost similar, right? They both start with C for it. So now, this is how you'd remember that at a cold front that starts with C, we've got cumulus and cumulonimbus clouds. Now, another thing that I want you to remember is that cumulonimbus clouds, these are densely packed clouds. They are densely packed clouds, very huge clouds. They are bigger. So then if they are bigger, it means they are going to bring heavy rainfalls. Good. They are going to bring heavy rainfalls, sometimes with even thunderstorms and lightning. Are we good? Right. Let's move on to the next one now. We're going to look at the conditions within a warm front. Now in the warm front, guys, it's going to be mostly the opposite of what we said in the cold front. So for starters, in the cold front, we said the air pressure is going to increase. But here, because we've got warm air, which is causing the air to rise, which is going to cause the air to rise, that means our pressure now is going to drop. That means you're going to have a deep low pressure, right? So because now the air is rising, what's causing the air to rise? What's causing our air to rise? It's because of very good higher temperatures. So the temperature is going to increase within our warm front, because warm air is arriving. Obviously, now our temperatures are going to increase. Now with temperatures increasing, we've mentioned now that we're going to have warm air rising. Now when the air rises, guys, it rises along with the moisture. It rises along with the moisture, which is going to cause humidity to increase as well. Right. Now with this moisture now rising, it's going to go into the atmosphere now and condense to form, very good, it's going to form our clouds. Now here it forms very small clouds, not as large as the cumulus and cumulonimbus clouds, but it forms cirrus, which are thin and long clouds. They're not as big as the cumulonimbus clouds. Then followed by the stratus clouds. For both of these clouds, they are smaller compared to the cumulus and cumulonimbus clouds. Now if our clouds are smaller, it means our rainfall is going to be light. We're going to have light rainfalls. Gentle rainfalls fall from our nimbostratus clouds. Are we still together? Thank you. Right, so let's look at the next front now, which is known as the occluded front. Now within our occluded front, guys, our occluded front is separated into two. Our occluded front is separated into two parts. We've got a cold occlusion and a warm occlusion. Now I want you to pay very good attention at this one, because it can be a bit confusing at times. Okay, so a cold occlusion is what mostly happens. Let me draw just a simple diagrams to explain this. So this is your cold occlusion. So we've got a cold front here, then we have a warm front ahead of the cold front. So we've got cold air here, we've got a warm air here. Right about here, this is where the clue is. This is where the clue is. We've got cool air. Very good. Right. Then this is your cold occlusion. Then this is how your warm occlusion would look like. Well, we still have a cold front here. This is your cold front. Then this is your warm front. Okay. Then what type of air do we have here in terms of temperature? Good. We've got cold air. Then here, obviously, it's warm air. It's warm air. What about here? I said this way the clue lies. So here we've got colder air. You see what I'm saying? Colder air. Let's explain the cold occlusion first. We said this is our cold occlusion here. And a cold occlusion happens when this cold front moves forward. Now what does it do when it reaches the warm front? It leaves the warm front. When it reaches the warm front, it leaves the warm front. This is your cold occlusion. As you can see, we're saying it forms when the overtaking cold front leaves the warm front because it's much more colder now. The warm front is warmer, and therefore its weight is light. It has got a light weight. So that's why it's going to cause the warm front to be lifted or to rise. Plus the air mass ahead of the home front. Because this air now is much colder than this air mass ahead of the home front, it's going to lift the home front and lift the cold air as well, because it's much denser than both of these air masses, both of warm and cool air. Are we good? Right. Then this is your warm occlusion. How does this one now happen? It happens when this cold front now is the one that is going to get lifted up now, right? You see what I'm saying? It's lifted by the colder retreating air. Sometimes this air is going to retreat back and cause this cold air to be lifted up. See what I'm saying? What's caused this cold air to be lifted? Because this one that comes this direction is much more colder than this one, right? That's why when you read here we say it forms when the overtaking cold front, this front that is overtaking the home front, is the one that is lifted by the colder retreating air. By the colder retreating air ahead of the home front. You get the difference between the warm and the cold occlusion. Good. So a warm front occlusion weathers are similar to a warm front weather. If you remember the characteristics of a warm front. So this one in the warm occlusion are similar to that one. Good. So, I forgot. These are the diagram. I forgot that I included this diagram. So, as we said, in a cold occlusion, we've got cold air here and cool air ahead of the warm front. Then here, on a warm occlusion, we've got cool air here and much colder air ahead of the warm front. Are we good? Thank you. Right, so guys, let's look at our next slide, which is about how to interpret satellite images and charts or synoptic weather map. Now, I'm going to be honest, I'm not going to dwell more into this one because it would be time consuming, okay? But anyways, I'm just going to give you a heads up on that. So sometimes they'll bring this synoptic weather map, then it's going to have a mid latitude cyclone. This is your cold, this is your warm front. Then there might be 1080 HPA here. Yeah, you might have 1084 HPA. Then they say now give the air pressure of X here. How would you give the answer there? You need to identify the isobaric interval now. What is the isobaric interval here? It's 4, because 1080 to 1084, the difference is 4 there, right? Now remember, the more you go towards the center of a cyclone, the air pressure decreases, okay? So it's 1084, 1080, that means here it would be, yes, this would be 1076, okay? Then here it would be 1072. You see? Now sometimes they will say label front A, this is your cold front. Label front B, this is your warm front. right? Sometimes there will be they say label L. If it's there at the center of a cyclone, you need to label it as a mid-latitude cyclone, right? Okay, what else can I make you be aware of? Okay, I'm just going to stop there. Let's move on. Okay, so these are your mid-latitude cyclones. Now the question is, what's the difference in terms of the location between these two cyclones? We've got cyclone A, we've got cyclone B. What is the difference between these cyclones in terms of their location? Let me give you 5 seconds to find the answer. Have you found the answer? Good. So the answer is this one. When you look at this one, can you see that in which direction is it circulating? It's circulating in a clockwise direction, and then this one is circulating in an anti-clockwise direction. So this means now this one is in which hemisphere? Northern hemisphere? No, it's not northern hemisphere. This is in the southern hemisphere. Okay, this is in the southern hemisphere because it's circulating in a clockwise direction. This one, because it's circulating in an anti-clockwise, this is in the northern hemisphere. You see what I'm saying? Cool. So, and this is where our tutorial ends, guys. I hope you managed to take and grab a lot from this lesson. Otherwise, let me just tell you about our next topic. Our next topic is going to be the tropical cyclones. All right, so stay tuned for that one as well. Bye-bye.